All right, this is a second video in a series about rationalizing denominators. So today we're going over rationalizing a cube root. But the technique that I'm going to show you not only works with a cube root, but a fourth root, fifth root, even a square root. As mentioned with the square root video, anytime you have a radical, if you want to try to you want to try to simplify if you can. In this case, there's not much you can do to simplify. Here's why. You start with 18. That's like saying 9 times 2. So I'm going to do a prime factorization here. 9 is 3 times 3. So another way of writing this 18x is like saying 3 to the second, because 2 3s times 2 times the x. And yeah, there's nothing I could go ahead and take out of that cube root right there. Same applies for the numerator where I have a 2y squared. Let me rewrite that y. That looks horrible. Yeah, there's nothing I could take the cube root of in there. Okay, so first thing you want to do is always see if you can simplify your radical first. Okay, it just makes things a little easier for you. And the way this works is as follows. This is how you actually go through the rationalization of the denominator. Based on the value of the index, that's like the 3, okay, the number side, the number n on the nth root, what you want to do is you want to have it so you multiply by whatever exponents you have for each of these numbers, such that you have a total of the number that you have here. So I know that's a lot of talk there, but see if this makes up for it. So if I looked at 3 squared, you have 2 3s, so I'm going to go ahead and excuse me, add in 1 3 here, 3 to the first. I have for the 2, I have 1 2, so I'm going to put 2 2s, 2 to the second. And for the x, I have x to the first, and I'm going to go ahead and multiply by x to the second. Okay, so that 2 and this 1 add up to 3. 2 and this 1 right here, sorry, that's the little dot, this is supposed to be a 1. 2 and 1 add up to 3, and then for the variables 1 and 2 add up to 3. So again, you will go ahead and multiply by the exponent that's needed to give you to the index. And the next thing I'm going to do is use properties of exponents, which tell me that you can go ahead and, properties of radicals that tell me if you take the cube roots of 2 expressions that are positive, you can put everything inside together. And I am assuming the variables are positive here, by the way. So this would be 3 squared 2x times 3 to the first 2 squared x squared. And that total will give you the cube root of 3 to the second and then 3 to the first, make 3 to the third, 2 to the first and 2 to the second is 2 to the third, and x squared is x to the third. Okay, that is what occurs with that radical. Now you don't have to write out all these steps here, but I recommend people do that. It's when you're starting off. But I just don't do that to the bottom. I got to do that to the top as well. You get 3 to the first, 2 to the second, and x to the second. And you would get 4 times 2y squared. So when you multiply this stuff together, you would have, let me actually just put that here, 4 times the cube root of, you have a 2 to the third, a 3 to the first, a y to the second, and an x to the second. And again, this is from multiplying this and that, and that's what we left. And for the denominator, the cube root of 3 to the third, that's just 3, that would come out like that. The cube root of 2 to the third is 2, and the cube root of x to the third is x. And another way to look at it is this way. Think of 3 in here divided by 3 is 1, 3 divided by 3 is 1. But anyways, when you do that, when you get the same index here and is here, all those powers cancel out, and all you have left are the bases of those exponents. And then on the top, I would have 4 cube root 2 cubed 3y squared x squared, and the cube root of 2 cubed, that's 2, and you would just have a 3y squared x squared. And I do not care that I have still a radical on the numerator. That's because we're rationalizing the denominator, not the numerator, so that's fine. And I can cancel a bit here. The 2's cancel, and we got 3x 4 times the cube root of 3y squared x squared. All right, so that does it. So just to recap what we did here, the first step is always try to simplify your radical if you can. But we factored the 18 out, and nothing could be factored out of that. So we wrote it as 3 squared times 2x, so we write it in terms of a prime factorization. And if you had 3 squared, well, in a 2 and an x, we ask ourselves, how many more 3's, 2's, and x's do you need to get to the index, the 3? So if I had a 3 squared here, I needed 1 3. If I had 1 2, I needed 2 2's, and etc. for the x. And that's what you multiply the numerator and denominator by, okay? And for the denominator, you basically get that always cancels out, and you get 3 times 2 times x. For the numerator, well, you just have to wait and see what you have and see what you can simplify this down to. And we went ahead and multiplied. We got the cube root of 2 to the third, 3 times y squared x squared. We could pull the 2 out, and you would just have the cube root of 3y squared x squared. One note about how I wrote this is a little sloppy on my part. That 3 really should be more up here, because the way I had it, looks like it was on the 2. And that presents problems because a lot of people think, oh, you're talking about 2 to the third or something, which obviously we're not. So just be careful with that when you're writing that out. Okay, thank you for your time, and I hope this helps.